Hi, I'm going to do right now in this video. I'm going to talk about what I think is actually one of the more interesting theorems in geometry, and it has to do with the properties of secants and circles. And as you may recall, secant is any line which passes through the circle like this, not like a tangent where it just touches at one point. It actually passes through the circle. So here we have a secant going through here, intersects the circle at point A, and then exits the circle at point B. Here we have a second secant also going through point P right here, intersects the circle at C and D. Now this really interesting result, which is illustrated with a little Java applet here, is that the product of the long line PB, okay, times the shorter line PA is equal to the product of this longer line PD times this shorter line PC. So this product, the short line times the long line, equals this product, short line times the long line. Now the actual value of the product changes, but for these two lines, that product is always equal. That's illustrated up here in the corner. This is computed by the Java applet. And here we have 16.1 times 26.4 is equal to 15.4 times 27.6, and the products are equal. Now watch as I move this point P around, the product changes, but the two products are still equal. Now I'm going to keep moving this around. I'm going to try to get the point A to actually correspond with the point B. So that makes the point PB a tangent. There we go. PB is now a tangent, and we still have now it's 19.9 times 19.9 because the short line and the long line are the same. Still equals the short line 14.4 times the long line 22.3. Okay, so the product is still equal. So no matter where we put this point P out here, anywhere around, look at that. And now I'm going to get it around here and get the point CD overlap. And there we have that the product is still equal. Okay, so how do we prove this? I mean, these seem like they're almost arbitrary secants. In fact, they are very close to being arbitrary, except that they intersect at some point. Now, you know that except for when the two lines are actually parallel, any two secants will intersect. So it's almost all secants. This is for which this is true. So let me prove this. And so here I have a circle, just like in the previous Java applet, and I have the intersecting point P intersects the circle at AB and CD. Now, in order to prove this, like many proofs in geometry, we want to prove a result. We have to add some extra lines. We have to know which lines to add to make it work. Here I'm going to add this line right here, BC, and I'm going to add this line right here, AD. Now you may recall from a discussion earlier that if we have two inscribed angles in a circle, and this is an inscribed angle ABC, and this is an inscribed angle ADC, that intersect the same arc, that no matter how those angles are drawn, they're inscribed and they intersect the same arc, the two angles must be equal. So we have that this angle right here is equal to this angle right here. Okay? Now we also have that this angle here is common to both triangles. That's this triangle and this triangle. So we have two angles common, one angle in common, and two angles are equal. And because all three angles of a triangle must add up to 180 degrees, that also tells us that this angle right here is equal to this angle right here. Okay, because that's the remaining third angle in each triangle. Okay, that tells us that the triangle PBC is similar to triangle PDA. So those two triangles are similar. Now, if the triangles are similar, we know that that there are ratios which are going to be constant between the two triangles. In particular, we're going to look at the ratio of PB to PC. So the ratio of PB to PC. Okay, PB, this long line, to PC, this shorter side of the triangle, that ratio has to equal. Okay, those are two lines in this triangle. So we look at this triangle here. That has to equal the ratio of PD, this long line, to AB, this short line. No, I'm sorry. I think I got that. It's not this short line is to PA, this line right here. So let me write that down. I have PD. PD is this long line, and the ratio to PA, this short line. So what do I have? I have PB, this line, times PA. If I cross multiply here, I get PB times PA that has to equal PD times PC so PA, this line, I mean this line right here, times PB, this line right here, equals PC, this line, times this line, PD. So there we have proven right here that those two products are equal right there. So that is the result of one of the more interesting problems in proofs in geometry, one of the more interesting properties. And by the way, that Java applet can be found at this website right in here. So if you look at that, copy it down, put it in your browser, if that website's still up and running, you should see that really interesting Java applet. Okay, next time.